All right, in this video, we're going to look at the actual process of finding the inverse of a function. So first up, the notation for a given function like f of x, the notation for the inverse of the function is f, and then it looks like it's being raised to the -1 power, and then x in parentheses afterwards. It doesn't mean it's being raised to the -1 power, it's just the notation that we typically use to denote the inverse of a function. So how to find it is really a three-step process. Step one is, instead of f of x or g of x or h of x or whatever, write it as y equals. So we're going back to y equals instead of a function notation. Then switch the x and the y. You're going to switch your x and y variables. And step two is got a lot of ideas and concepts we'll look at a little bit later on behind it, working behind the scenes. And then step three is where the bulk of the work is, where you're going to solve for y after you switch them and then rewrite your function using inverse notation. So example 2, we're going to find the inverse of each. F of x equals 1 minus 2x over 5. So we saw that in the last video, this does pass the horizontal line test. Now we're actually going to find what the inverse function actually is. So step one, we're going to write this as y equals instead of f of x equals. That's a pretty easy step. Step two, we're going to switch the x and y. So anywhere we see an x on the right-hand side, we're going to put a y there, and we're going to put an x over here on the left. So there's only one x term on the right side, so there's only one y term. So I'm going to make this in red, so I remember that I'm trying to get this red y by itself. Red y. First, multiply both sides by 5 to get rid of the fraction. We'll get 5x equals 1 minus 2y. Then we can subtract the 1 from both sides. We'll get negative 2y equals 5x minus 1. So subtracting 1 from 5x. And I just switched them around. You don't have to switch them around. And then finally, divide everything on both sides by -2. So we get one acceptable answer. It's 5x minus 1 over -2. That's perfectly fine if you'd like to stop there. However, if you want to, instead of having the negative in the denominator, distribute the negative to the numerator, you'll get negative 5x plus 1 over positive 2. So either this here, the negative 5x plus 1 over 2, or the 5x minus 1 over -2, either one of those is acceptable. All right. Again, our goal is to get the red y here by itself. Once we do that, we'll just use inverse notation for it, and we're done. So if we give our original function a value, such as, let's go with 0, we're going to get 1 minus 0 over 5 is 1/5 in return. Well, if we have the 1/5 and we want our 0 back, then we should give the 1/5 to this function, and it'll give us our 0 back. -5 times 1/5 is -1. -1 plus 1 is 0. And 0 divided by 2 is 0. So this function will undo anything we give this function. All right, part B, g of x equals 2x over 1 minus x. So we'll write this as y equals 2x over 1 minus x. Switch our x's and y's, and in this case we have an x in the numerator and an x in the denominator, so we're going to have a y in the numerator and a y in the denominator. So that's perfectly fine and absolutely possible. I don't like fractions any more than the next person, so I would multiply both sides by 1 minus y to clear out my fraction. And we get x times 1 minus y equals 2y. Next step, distribute our x to both terms. We'll get 1 times x is x, and then x times -y is minus xy equals 2y. And we want to get these red y's alone, and in essence, we want to get them on the same side of the equation. So now we can bring this -xy over by adding it to both sides, and we're going to get x equals, when we add this -xy to both sides, we get 2y plus xy. Notice both of these terms on the right-hand side now both have that red y as a common factor. So whenever you have more than one y in your process of finding your inverse function, try to group all of your y's on the same side so you can factor a y out and then solve for it. So when we factor out a y, we get y times 2 plus x, or x plus 2, it really doesn't matter. So to get red y by itself, divide both sides by 2 plus x, and we get red y equals x over 2 plus x. So now we can just use the inverse notation. We started with g of x, so it's the inverse for g. I'm not overly picky on this part here. I'm looking more at the process of getting the inverse function. So if you put f inverse of x, even though the function was g of x, it's not the end of the world. But this is our inverse function, so x over x plus 2. So this will undo the effects of the last function for values in that domain, which we'll talk about in the next video. All right, example 2c, we have h of x equals the square root of x plus 2 and then minus 1. So we have y equals the square root of x plus 2 and then minus 1. So switch our x and our y, and we get x equals the square root of y plus 2 and then minus 1. So we want to get this red y by itself. We have this minus 1 that's outside the square root, so let's add that to both sides. We get x plus 1 equals the square root of y plus 2. So to free up the y plus 2 inside of a square root, we're going to square both sides. So we have x plus 1 in parentheses squared equals y plus 2. Now you could multiply out x plus 1 times x plus 1 and simplify it. But for this part, let's just, we'll skip that step. But if you're gung-ho on it, go ahead. So now to get red y by itself, subtract 2 from both sides. And now that we have the red y all by itself, this function on the left-hand side is our inverse. So we have the inverse for h is x plus 1 in parentheses squared and then minus 2. All right, so that about does it for this video. In the next one, we're going to take a look at the domain and range of inverse functions. So I'll see you then.